Hello students, today's agenda is to check homework. We'll be learning about the sine and cosine, and you will be able to do 10.4. Today students will be able to calculate cosine and sine for special angles, and this is going to be by using our unit circle that we filled out in the previous lesson. But before we do that, we're going to show you how we get to these values. Okay, how do we get we said that this is the cosine and the sine for that specific angle, an angle of 30 degrees or pi over 6 radians. This is its cosine and this is its sine. Okay, so we're going to use this so that we can familiarize ourselves, but we need to understand where do they come from, and you can use the unit circle that you filled out already for this lesson, but I'm going to be using this so that it can, if we have a triangle with these 3 dimensions and we have this angle, there is always going to be a relationship between the ratio either of sine to that angle or cosine. So what is sine and what is cosine? Let me show you. So in here we say that sine of A is equals to the opposite over hypotenuse. Opposite over hypotenuse. And the opposite to that angle is 4 over the hypotenuse is always the longest side, is 5. And if we divide 4 divided by 5, 4 divided by 5, that's equals to 0.8. That's its ratio, okay? And that's specific to this angle. Now, let me show you, if you remember how to get that angle from a previous lesson, and if you don't, I'll show you right here. It's going to be second, and since it's sine, it just, for the second function, is just the inverse of sine, which you can see. Let me get it closer. It's sine -1, which means the inverse of sine, okay? And we press that, and 53.13, and it's rounded to that, okay? So that's the relationship. Now, if we were to say, let's give this a different value, let's double it. So instead of 4 units, it's going to be 8 units. Instead of 5, it's going to be 10 units. Sine of A is equals to opposite over adjacent, which is 8 divided by 10. The ratio between these two simplifies to half of 8 is 4, half of 10 is 5, which is again 0.8. So even if this doubles, it's still the same ratio. So whenever we have these two sides being the same ratio, then that means that that angle is going to be the same. And again, because even if you put 8 divided by 10, the inverse of sine is second, and sine is 53.13. So what does that mean? That for a specific angle, if this grows, then this will grow as well. Now let's do it with a cosine. Cosine of A is equals to adjacent. Adjacent is the one that touches that angle, but it's not the hypotenuse, okay? So adjacent over hypotenuse. And the adjacent is 3 units. The hypotenuse is 5 units. For that, 3 divided by 5 is equals to 0.6. Now, let's check to make sure that it is that angle, but now it's with the cosine. So 3 divided by 5, and we put the second and cosine because that gives us the inverse. The inverse is just giving us the measurement of the angle. So the angle that matches, let's say, with this ratio for a cosine is 53.13. So you can see that it's the same angle. So that angle matched with two sides that the ratio is 4 divided by 5 or 0.8. And that same angle, it doesn't matter how long the sides are, but the ratio, the comparison of the cosine for that specific angle will always simplify to 0.6 or 3 over 5. And let's do, just to make sure that, let's say that we double it just like we did. You can triple it, you can multiply it by 5, but the ratio will always stay the same, okay? So if we double this, it's going to be 6. So cosine of A, which is adjacent over hypotenuse, which is adjacent over hypotenuse, will be 6 over 10. That's when we doubled it. And I'm not going to simplify it. I mean, it will always simplify to 3/5 compared or matched with that angle, okay, for the cosine. So 6 divided by 10 is equals 0.6, the same, because it's simplified. It, for that specific angle, it always be 0.6 for the ratio of the two sides. And second function of cosine is the inverse of cosine, which is 53.13. And that's when we say that A is equals to 53.13. Okay, so now that we understand this relationship of sine is opposite over hypotenuse, cosine adjacent over hypotenuse, I'm going to try to show a little bit of where these relationships come from. Before we start with the lesson, let's understand a little bit of where these values come from. I'm going to do super fast so that we can just get to the lesson and you can start working on your assignment. Let's look at some theorems that we have seen in the past but need to review probably. So in previous lessons, it says that in a 45, 45, 90 degree triangle, both legs are congruent and the length of the hypotenuse is always the square root of 2 times that leg, okay? Meaning that we have the square root of 2 multiplied by x in this case. If this is a 1, then it's going to be the square root of 2 times 1. If this is a 2, square root of 2 times 2. If this is a 5, square root of 2 times 5. Okay, that's the relationship between the hypotenuse with either one of the legs. And we'll see how that relates to the unit circle. For the other theorem, it says in a 30, 60, 90 degree triangle, the length of the hypotenuse is twice the length of the shorter leg. So let's stop right there and then we'll come back to the rest. So the length of the hypotenuse is twice the shorter leg. So the shorter will usually be the number alone. That means that you just multiply times 2 and you get the hypotenuse. If this is a 5, 2 times 5 is 10. If this is a 4, 2 times 4 is 8. So it's just going to be twice as long. The rest of the theorem says the length of the longer leg is square root of 3 times the length of the shorter leg. So you're just going to multiply the shorter leg times the square root of 3. And you can put it over here or you can put it over here. Okay, it doesn't really matter. But you're multiplying the two. So in here we have, it's exactly the same thing, but it's flipped and rotated as well. But it's just so that you see the relationship once we compare it to the unit circle. Okay, having that in mind, let's look at the two comparisons and let's see how does this relate. And I'm just gonna look at the ones on quadrant 1 so that you see and do a little bit of math in here to show you how we get to those values. The sine of, in this case, the 45 degree angle is going to be equal to the opposite over hypotenuse, meaning x over square root of 2 times x. whenever you have the same thing in the numerator and denominator, we can cancel that. And we get 1, right? 1 over square root of 2. But we cannot really have a square root in the denominator, so to cancel it, we always multiply by the square root of 2. It's square root of 2 divided by square root of 2 is, we're multiplying by 1, right? Anytime that you're multiplying by the same over the same is just like multiplying by 1, and so it doesn't really alter the value in here. Okay, so 1 times the square root of 2 is the square root of 2 over, in here, square root of 2 times square root of 2 is the square root of 4. This cannot be simplified, so it's just the square root of 2 over the square root of 4 is 2. So if you notice, square root of 2 over 2, that's what we have in here. But it's for the sine. If you recall, this is cosine, this is sine. So that's this value right here. Now, if we do the same thing for cosine, and let me move this because I see the letters underneath. So cosine of 45 is equals to, let me move it down here. Adjacent, which is the leg touching it, which is not the hypotenuse. This is the hypotenuse, so it would be this one. And again, it's going to be x over the hypotenuse, okay? Adjacent over hypotenuse, which is square root of 2 times x. The x cancel, and this is again the same thing, so we multiply by the square root of 2 and square root of over the square root of 2 and simplify it to be the same. Okay, since it's the same value, the result is going to be the same. So that's where cosine of that, and this again is just because that's the 45-degree angle. Okay, in here 45-degree angle, we form this down here, and that's my 45-45 triangle. Now let's remove this. We know where those values come from, but what about this one? Well, now let's look at this triangle right here. That's a 30-degree angle, and so that means that again we're forming a triangle here per se. And so, again, the sine of this angle, which is a 30-degree angle, it's going to be equal to opposite over hypotenuse. But we already know from this rule that the opposite is going to be x. Hypotenuse will be 2x, which is going to be equals to, since this cancels, x divided by x is 1, and you just bring over the 2, and that's it. So sine of 30, which is this angle right here, this right here is 30 degrees. So the sine is 1/2. Remember, sine is the second one, cosine is the first one, okay? So that's where that comes from. For cosine of 30, it's adjacent over hypotenuse. So it will be adjacent over hypotenuse. Adjacent is going to be x square root of 3 over 2x. In here, the x cancels, and you are left with square root of 3 over 2. So that's the cosine of a 30-degree angle. That's where it comes from. Again, once we have the unit circle, we're just going to kind of use the unit circle, but I just wanted to show you how you get to it. And for this one right here, that's a 60-degree angle, so that's why I decided to use this other triangle where we have it's the same, right? The relationship is the same, x for the smallest, 2x for the hypotenuse, and for the long leg is square root of 3 times x, or x times square root of 3, same thing. So I just want you to see it easier in here. So if we go back to our unit circle in here, this forms a triangle. If you bring down this line, and that's your 60-degree angle, okay? 60 degree. So again, what's the relationship? For the sine of 60 degree now is going to be equals to, again, sine is always opposite over hypotenuse. So opposite is right there. So in here, opposite will be square root of 3 times x over hypotenuse. Hypotenuse would be this value right here over 2x. This cancels. And so we're going to get square root of 3 over 2. Again, that's the sine. The sine is on the y coordinate. And so it's going to be square root of 3 over 2. That's where that came from. Okay. Now for the cosine, meaning the x value on the unit circle, cosine of 60 degree, this is the 60 degree, is going to be, again, adjacent to that angle, okay? The 60 is right here, so adjacent will be the side touching it, so it's going to be x divided by hypotenuse, which is 2x. The x cancels. Let me show you with that. And so you have 1, because x divided by x is 1, and you just bring over the 2. So 1/2. That's where that 1/2 comes from. Again, if you remember from the previous lesson, you just put a 1, 2, 3. 1, 2, 3. All denominators are 2. And you just put the square root in all the numerators. However, the square root of 1 is always 1, and that's why you don't need to put the square root on the 1. But you put it on the square root of 3, square root of 2, and square root of 3. Okay, so now that we know where those values come from, we're ready to use our unit circle. So now for this assignment, it's going to be super simple because we want you to start getting used to the unit circle, and then we'll go into more complex ones. So for this lesson, you don't need to know any formulas other than using your unit circle. So remember that the one on the x is your cosine, the one on your y is the sine. And so those are what we're going to be using, and it's the same for all. Okay, x is cosine in alphabetical order. C comes before S. X comes before Y. So both are in alphabetical order. So now let's go to sine of 30. 30 is right here. The sine is going to be equals to 1/2. That's all you have to do for this assignment. Super simple. We just wanted you to understand where those values come from. And so sine of 45. Sine of 45. Oh, sine is the y value, so it's going to be square root of 2 over 2. And again, I know it's super simple, but then it's going to be very handy when you understand how to find these values, because we're going to be learning more complex combinations, okay, of trigonometric ratios. Sine of 60. Maybe you want to pause the video and then do it before I find them so that you can get used to it. And maybe try not to write this, or write it if you feel that's going to help you. But ideally, you want to know what each one represents without writing it. Okay. Sine of 60. Sine of 60 is going to be square root of 3 over 2. So that's what we're going to be doing, just identifying how to go and grab those values for now. Now let's go to our cosines. So cosine of 30-degree angle. You go to the 30-degree angle. The cosine is the first value, so it's going to be square root of 3 over 2. What is the cosine of 45 degrees? Oh, 45. Cosine is the x value, so it's going to be square root of 2 over 2. Cosine of 60. Cosine of 60 is the first value, which is 1/2. that simple, okay? It's just being able to find the right values for our sines and cosines. And now we have here sine of 0 degrees. Sine of 0 degrees, this is my 0 degrees. Sine is the second one, so it's equals to 0. Cosine of 0, cosine is the x value, so it's going to be equals to 1. Sine of 90-degree angle, sine is which one? Oh, the y value, which is equals to 1. And cosine of 90 degrees, cosine is the first value, or the x value, so it's going to be equals to 0. But sometimes we're going to be using the radians. So that's why we really need to have our unit circle in front of us. Sine of pi over 4. Sine will be the second value related to pi over 4. Now it's not going to say sine of 45 degrees, but the radians is pi over 4. So it's going to be the second value, which is square root of 2 over 2. Cosine of pi over 6. So we look for pi over 6, which if you remember, these are opposites, but the cosine is the first value of that, which is square root of 3 over 2. Remember that denominators are always 2. Cosine of pi over 3. Cosine of pi over 3, cosine is always the x value, so it's going to be 1/2. And sine of pi over 2, pi over 2 is right here. I recommend that you fill all this information 2-3 times, because that helps you so much to memorize these values. The more you fill it out, the better you get at it, to understand it, to remember some of the values, or just fast get familiarized basically with the unit circle, and you'll love it. So sine of pi over 2, sine is the second value, pi over 2 is right here, so it's equals to 1. Sine of 3 pi over 4, I know that if it has a 4, it's one of those 45 degrees. The 45, this one or this one. So 3/4 is right here. And sine is the second value, which is equals to square root of 2 over 2. Oops. Over 2. And cosine of 3 pi over 4. The cosine is the first value, so it's negative square root of 2 over 2. Okay, so always remember the first one is cosine, the second one is sine, and you just look at what they're asking you for. Okay, today's homework is going to be super easy, but it's going to be helping us. It's the foundation for later lessons, so it's super important that you practice this, but really understand which one is sine, which one is cosine. In your homework, some of the examples are going to be very similar, so try to not look at the examples that we have here when you're filling it out, but if you need to, go ahead, because that's how you're going to practice. Greatly be appreciated if you can give us a thumbs up. You can subscribe around here. You can find the entire unit, the entire playlist for this unit in here, and over here is going to be your next, and around here you will find the next video. Now you're able to do 10.4, and don't forget to always have fun.